Hello, and welcome to the Math Connection. My name is Miss Lenz, and today we are going to talk about multiplying polynomials. So our questions are going to look like this one up here. We're taking x plus 4 times x squared plus 5x minus 8. One thing to note is that we know we're multiplying because there is no sign in between those parentheses. So if there was a plus sign, we'd be adding. If there was a minus sign, we'd be subtracting. There's nothing written here. That tells us that we are going to be multiplying these polynomials. So we have already talked about multiplying polynomials, but we only talked about multiplying binomials. If you'd like a refresher on that, you can click on the video that's up here, and that'll remind us how we multiplied binomials. And that's helpful because this is just an extension of that. It's just doing the same step but more times because it's a bigger problem. So when we multiplied binomials, we took two factors that had two terms each in them. So it would be like multiplying x plus 4 times x minus 6. We have two terms in both of those. And what we said when we do that is we can distribute. We can take x times x and x times negative 6. But not only do we distribute the x, we also have to distribute the 4 to each term in the second parentheses. We have to take each term in the first parentheses times each term in the second parentheses. So this is how we did binomial times binomial. But if we look at what we're doing today we are trying to take a binomial, which remember has two terms, like the first one, x plus 4 is a binomial, and we're trying to multiply it by something that has three terms, x squared plus 5x minus 8. But we're going to have the exact same mindset as when we were taking a binomial times a binomial. We want to just distribute each term in the first parentheses into each term in the second parentheses. So let's start with our x. We want to take x and we want to multiply each term in the second parentheses by it. So x times x squared is how I would start. X times x squared gives me x to the third power. X times 5x gives me a positive 5x squared. And x times negative 8 gives me a negative 8x. And this is what I get when I distribute just the x into the second parentheses. But I can't stop there. I can't just distribute the x. I also have to distribute the 4 into the second parentheses. So I want to take 4 times each term in the second parentheses. So starting with 4 times x, 4 times x squared. 4 times x squared is a positive 4x squared, and I'm going to stack that underneath the 5x squared because those are like terms. Just an easier way of organizing them. So 4 times x squared was 4x squared. Next one is 4 times 5x, which gives me a positive 20x. And the last one is 4 times negative 8, which is a negative 32. And that will go at the end because there are no terms that are like that one. Now there's nothing else to distribute because I took both of those terms in the front times each term in the second parentheses. So now I'm just combining my like terms, which I've made easy on myself because I can just combine my columns because I organize them like that. So my first column has just an x squared. That can't be combined with anything, so I'm just going to bring that term down, x to the third power. My second column has a positive 5x squared and a positive 4x squared. If I combine those, I get a positive 9x squared. That'll be my next term. And my third column, negative 8x plus 20x, will give me a positive 12x. And lastly, that negative 32 at the end will just come down because there's nothing to combine it with. So this is my final answer. This is what I get when I multiply those two polynomials, a binomial times a trinomial. Now, let's see what happens when we flip it. Let's put our trinomial in front and my binomial at the end. So let's multiply these. Let's take x squared minus 9x plus 1 times 3x plus 5. So this one is very similar to that last one. I'm still taking a binomial times a trinomial. We have two terms in this one, and we have three terms in this one. but they're just flip-flopped, okay? So there's several different ways you can think about this. Some people like to just reverse distribute. So you'd take 3x and you'd distribute it backwards, kind of. And then you'd take 5 and you'd distribute it backwards also. And that's totally fine. Another thing you could do is you could just rewrite this. Remember that multiplication, we can multiply in any order. So if I wanted to take the 3x plus 5 from the end and move it into the beginning, you can do that, and then it looks exactly like what we just got done doing. Or we can just distribute like we just talked about, except this time we have 3 terms to distribute. So I'm going to do it this way just because it looks a little bit different. So first we're going to take x squared and we're going to distribute it to each term in the second parentheses. X squared times 3x, which is 3x to the third, and x squared times a positive 5, which is a positive 5x squared. So that's what I get when I distribute the x squared. My next term that I have to distribute is a negative 9x. Do the same exact thing with this. Negative 9x times 3x gives me a negative 27x squared. And remember, I'm going to stack it with its like term. So it's like 5x squared because the exponents are the same. So that's the column that it needs to fall in. Negative 9x times 5 is my next one. Negative 9x times 5 is a negative 45x. That one doesn't have any like terms, so I'm going to put it here at the end. So I've distributed the x squared. I've distributed the negative 9x, but I do have one term left because there's 3 in my first one, and it's a positive 1. So I need to do the exact same thing. Just distribute that positive 1. So 1 times 3x gives me 3x, and I'm going to put that underneath the 45x because those are like terms. And then 1 times 5 gives me a positive 5, and that will come at the end because that one doesn't have any like terms. Now I've distributed everything in the first parentheses to everything in the second parentheses, so now I can combine my like terms. So my like terms are, in that first column, we don't have any like terms, so we just have to bring that 3x cubed down. My next column, 5x squared minus 27x squared will give me a negative 22x squared. Next column, negative 45x plus 3x will give me a negative 42x. And my last one is that plus 5 will just come down at the end because it doesn't have any terms that are like it. So this right here is my final answer. Our setup just looks a little bit different, but we're having the same exact thoughts. We're just distributing each term in the front to each term in the back. Okay? Now let's try one more together. This was a trinomial times a binomial. Let's try a trinomial times a trinomial. These will say multiply, but they also might say expand, same thing. So let's take 3x squared plus 9x minus 2 times x squared minus 2x plus 4. So we have a trinomial times a trinomial, 3 times a 3 in this one, okay? But again, same exact thought process. So let's start by just distributing the first term. 3x squared, we want to distribute to each term in the second parentheses. So 3x squared times x squared gives me a 3x to the 4th power. 3x squared times negative 2x gives me a negative 6x to the 3rd. And 3x squared times 4 gives me a positive 12x to the 2nd power. So here is when I distribute just the 3x squared. Next term I need to distribute is that positive 9x. Same thing, multiplying it by each term in the second parentheses. 9x times x squared gives me 9x to the 3rd power. Again, you want to stack your like terms. So I'm going to put 9x to the 3rd power right here. 9x times negative 2x gives me negative 18x squared. And 9x times 4 gives me a positive 36x. Okay, that's distributing my second term, but now I have a third term in that first parentheses, so let's distribute the negative 2 to each term in the second parentheses. Negative 2 times x squared gives me a negative 2x squared, and I'm putting it in the same column as the x squareds because they're like terms. Negative 2 times negative 2x is a positive 4x, and negative 2 times 4 is a negative 8. Now there's nothing else in that first parentheses to distribute. I've distributed everything, and now I can just combine my like terms. And they're in columns again for us. It's an easy way to organize them. 3x to the fourth doesn't have any like terms, so that will just come down. And I almost wrote a 3, but I need a 4. Negative 6x to the third plus 9x to the third gives me a positive 3x to the third. Positive 12x squared, negative 18x squared, and a negative 2. I'm going to put these two together first. That'll give me a negative 20, and then a negative 20 plus 12 will give me a negative 8x to the second. My x's, 36x plus 4x will give me a plus 40x. And that subtracting 8 at the end doesn't have any like term, so that will just come down at the end as my constant term. And this is my final answer. This is what I get after I distribute everything and combine like terms. Now I want to show you one more thing because we're going to have another method. So the way that we multiplied these polynomials is that we used the distributive property. So we can distribute, okay? Now, one thing that we talked about when we were multiplying binomials is that we can use FOIL. And FOIL only works when you're multiplying a 2 times a 2. So if I look at this one that we did, we were multiplying a 3 times a 2. You can't think of this as FOIL anymore, okay? You can only do it when it's a 2 times a 2, not anything more than that, okay? So the way that we learned to multiply polynomials was to distribute. There will be another video. If you want to click on that video, it is right here. And that will show us how we can use the box method to multiply polynomials. Just another method of doing the exact same thing. Thanks for joining me today. Please hit subscribe if these videos have been helping you. And I hope to see you soon.